Hey, what's going on, guys? Let's do this problem right here. The question is asking the volume and the average density of irregularly shaped body are to be determined by using a spring scale. The body weighs 7,200 Newton in the air, so air, and 4,790 Newton in the water. Determine the volume and the density of the body. State your assumption. So let's see how we can do this. So first of all, we have to find the volume. So in this case, they are saying this is they are measuring this one in the water, right? So it means this is an irregular shaped object. If it's in the water, we can use Beyonce force. So what is Beyonce force? It's like the reaction force by the water, like reaction force by the water, and then. So to do that, I can do this. I can use Beyonce force equation. That's P is equal to V rho G. Actually, mg is equal to m is equal to V rho and G. That's how this equation came, because F is equal to mg, right? So V rho G, rho water, volume of the object. So from this one we can find the volume. So volume is the question. P is equal to Fp over rho water times G. So in this case, we had to find out the Fb. I can calculate the Fb by using these two things, because the weight that we measure in the air is going to be the actual weight, and the weight measured by water is going to be deducted by Fb. Like when we put this one in the water, we have a mg acting downside, Fb acting upside. So the measurement is showing without a mg minus Fb is equal to the weight that we measured in the water, 4790. Therefore Fb is going to be equal to mg minus 4790. The actual weight we already know, that is 7200. So all we have to do is simply deduct this 7200 minus 4790, and that gives us 2410 Newton. So this is the one we are going to use right here. So this is going to be 2410 Newton divided by rho. So density of the water is 1000 kilogram per meter cube. So that's what we are going to use, 1000 kilogram per meter cube times 9.81. So if we calculate this one, this gives us 0.2457 meter cube. Roughly we can say it's 0.246 meter cube. So we have the volume right here. Then they are asking to find the density. We can find the density using this formula. Rho is the density, is equal to mass over volume. We know the volume already, that's right here. And we are going to calculate the mass. We can use this one to calculate, because 7200 is equal to mg. M is going to be equal to 7200 over G, that is 7200 divided by 9.81. That gives us 7200 over 9.81. If we calculate, that gives us 733.9 kilogram. So we have the mass right now. We can simply substitute that one right here and find the density. So this is going to be 733.9 kilogram per 0.2457 meter cube. And if we calculate this one, this gives us 2987 kilogram per meter cube. We can roughly say this is equal to 2990 kilogram per meter cube, and that is the final answer. And also they are saying they are asking you to state your assumptions. In this case, we have assumed that air doesn't create buoyancy force because it's negligible, because since air molecules are not together and it doesn't create much buoyancy force, and that's an assumption. And also we assumed that this object is fully dissolved in the water. That's when this volume is going to be true. So that is the two assumptions we have taken to calculate these measurements. I hope you guys like this video. See you next time.